Welcome all, welcome to this lab of object-oriented programming 1. Today we'll continue with your practical program list. Last time we had done practical number 14, now today we'll do practical number 15. Okay, let me show the disclaimer, then I'll start the session. Okay, so basically uh, we have done up to practical number 14 last time. Now today we will see how we'll implement this practical number 15. 15 is about binary to decimal, converting a binary number into decimal. That is or convert basically, it's like you enter a binary number which is in the form of a string. Okay, and the method is return bin to this like method which will convert a binary string into decimal number. So it's like something like this, that you enter, we know that binary numbers are something like this. This 0001 is equal to 1, then 0010 is equivalent to 2, then we know that 0011 is equivalent to 3, right? And similar, in the similar manner, if we say 0100 is equivalent to 4, right? So we know all these things, right? The people already know what are binary numbers, right? So what we want is user enters this left hand side and gets this right hand side as an output. In input, user enters the left hand side, that is the binary number in the form of a, it will be read as a form in the form of a string, and then it will be converted into a decimal number through a method like this. Okay, we have to implement that method basically. So we have to implement this bin to deck method that can throw a number format exception if the string is not a binary string. Okay, so basically this is an example where we can use specific exceptions. This is an example that which deals with also the strings and also a specific type of exception, that is number format exception. Okay, so let me take you to that particular program. Okay, so in this program you can see that the two methods are there. Okay, in this DTU practical number 15 we'll say there are two methods. One is the main method and another is this bin to deck method, which can throw a number format exception. You can see over here it throws, we are declared that it throws a number format exception. So wherever you call this, you will have to put it into a try catch which can catch this number format exception. And this bin to deck method has been made static so that it can be directly called inside the main method. So check this out. Let's see this main method, what is there inside it. If I open it, you can see over here that in this main method, first what we do is, check this out, this is the main method. In this main method, first we get the scanner object, okay, and then we display a message to the user saying please enter a binary number, okay, and we read it using the scanner object, and we say input.next. So what does this next do? This next reads the input and converts that input in a string form. So here we get the number inside a string form. So we have got a variable, we have declared a variable called binary number which accepts the string form of the number. Okay, and then what do we do? Check this out. Once we have read the binary number, that is the string format, binary number inside in the string format, what we do is we call this bin to deck by sending this string to this bin to deck method. Okay, and you can see that this bin to deck method has been put inside the try catch block. So if at all any exception occurs in this method call during the method execution, the control jumps and the exception has been thrown out of there and is caught into this catch block. Okay. So once we call this bin to deck, what does it do? It sends the control over there, it sends this value of binary number, whatever number the user has entered in the string form, and then it calculates the decimal number out of it and returns a decimal number. You can see that it returns an integer value. So we simply do what? We simply print it out. So this is the decimal number corresponding to the binary number. Okay. If there would have been any exception, we would say that the exception is this. We say exception occurred. And in the end, we close this what? Scanner input object. Okay. So this is our simple use of bin to deck method. Now let's see what is declared inside this bin to deck method. Okay. You can say it's a static method, so that's why it has been called directly over here. Inside the main method, it has been directly called. Since this is a bin to deck is also a static method, so a static method can easily call a static method, and main is a static method. So through that, we are calling this bin to deck method, and we are passing the binary number which has been read from the user in the string format. So we'll have to process this string format only. Okay. So check this out. How do we process it? So check this thing out. Here in this bin to deck method, we first say result is equal to 0. We declare an integer number with value equal to 0. Then we run the for loop that will convert the string into a numeric value. The string is nothing but, suppose the user has entered something like this 0011. Now this is in the string form. Okay. What do? We run this loop up to the length of the string. The length of the string. So we say for int I equal to 0, I is less than binary number dot length, and I plus plus. So every time in each iteration, what do? In each iteration, we get the character at a particular location of that particular string. So this is how we make use of char@. Method. Okay. We know that binary number, this is not a numeric variable, this is a string variable. So we can use char@ method on it, which is binary number dot char@, and we use the length, total length of the string. Okay. And we say minus I minus 1. So what is I? Currently I is 0. And what would be minus 1? So currently if the length is 4, you can see the length over here is 4. So that would be 4 minus 0. I is 0 minus 1. So it is equivalent to 4 minus 1, which is equivalent to 3. Okay. So the character at location number 3 is being used. Okay, we know that basically this in string also it starts with 0, right? So 3 would be this one, right? So this particular character is being taken into current bin value, character variable. Now what happens is, once we get that particular character, let's suppose this character has been taken over here, what do we check? We check whether that value is 0 or 1 or not. So each character is read one by one and also checked whether that is either 0 or 1. If it is not any one out of this, if current bin value is not equal to 0, and even if it is not equal to 1, then we have to throw the number format exception. So anyhow, any character of this whole string needs to be either 0 or 1, because we want input as what? Input as only the binary numbers, right? Now, if that is not the case, which is currently right now we have got this one and current bin value. So what we will do, we'll check whether that current bin 1 value is equal to 1, If yes, then only we have to multiply it with the that much power of 2, right? So what we do is we say if that is the case, which is currently the case, so the control goes into this if statement inside it, and it checks it calculates this result value by saying result equal to result plus math dot power 2 raised to I. What is I? I is nothing but the location. Sorry, I is starting with 0. So the power of this location is 0. You can see the power of this location will be what? It will be 0. Then similarly power of this location will be what? It will be 1. Similarly this is for 2, and this is having the power to be 3, right? So what do we do is we say math dot power 2 comma I. So 2 raised to 0, okay, that represents what? 2 raised to 0 is only the value 1, and that value is converted into integers. Since this math dot power would return a double value, it converts it into an integer and then adds it to the result. Okay, so similarly in the next iteration, if we see the string 0011, then in the next iteration again we get this particular one, and accordingly the I has been incremented to 1. So what happens is the current bin value is 1 only, so this if part executes and the old result is added with the new value of math dot power 2 to the power of I. What will be the I's value now? 1. So accordingly that 2 will get 2 raised to 1 becomes calculated, and this result value was already 1. So 1 plus 2 becomes 3. So then now the result is become 3. Next time when basically this 0 comes, okay, current bin value is not equal to 1. So nothing happens over here. Obviously this is not true. So this if does not execute. This if also does not execute, so nothing happens. Similarly, when this 0 comes, even the exception does not get generated, even, and this if also does not get executed. So once the loop ends executing this whole string, what do we have in hand? We have the result to be what? Result to be value 3. Obviously 3 is the number that is represented by this binary number, right? Obviously the 3 is the number that is represented by this binary number. So let's run it out and see whether do we get the same output or not. So here it says please enter a binary number. We enter 0011. Check this out, we enter 0011 and the output is decimal number 3. So this 0011 represents decimal number 3. This is binary number which represents decimal number 3. You can check any number. Take any number, let's say binary number. Let me give the number as 1001. You can see the answer is decimal number 9. Right? Similarly, if I give any number to be 1110 and say enter, you can see that is decimal number 14. Right? So in this way, it calculates the number, the decimal number, from the binary number. The binary number is entered and read into a string format, and character by character it is being converted into the what? Into the decimal number. Okay. This is how the binary to decimal execution takes place. Okay. First we have this method, main method, where basically we do the input part. In this main method we do the input part. Okay, here we read the binary number from the user, okay, in the form of a string. Then we call the bin to deck method, which basically where we pass this string format of the number, and then it is converted into decimal number and it is printed out, okay. And the second part is the major, we can say major logic part, where basically with this bin to deck method is sent the binary number inside the for loop. We extract a character by character. This is how we extract each character one by one. And see, remember this thing, we are starting to extract the character starting with the last position. Okay, we are uh, starting with the last position of the string. So basically, if the character is, if the string is 0011, we start with this last position in hand, then we go second last, and then we go third last, and then we go up to the first. And this is how we start. Okay, we start extracting the character from the last position. When we check if that character is not equal to 0 or 1, we throw an exception, and if it is 1, then you calculate the result according to the location of that particular, according to the location, that location value used to calculate the power of 2 to be added to the particular result. And once that result gets added, that value, right, then in the next iteration the next power of 2 gets added to it, okay, if that value is 1 only then, okay, if that value is 1 only then, okay. And in the end it returns the result, which is nothing but the integer result. You can say it returns an integer, right? Okay. So this is the simplest most program, where there are two methods. One is to read the read the binary number in the form of string and displaying the output. Second is the actual calculation of binary to decimal. Okay, by extracting each character and converting into a particular a particular expression, putting it into a particular expression, and calculating the result. Okay. So that is simple binary to decimal program, which deals with the methods being implemented on string, like the caret method. Okay, and we also saw the use of power method from math class. Okay, and then we also saw how number format exception can be thrown if the number is basically not as per our format. Okay, so any doubt in this, please do let me know. Yes, any doubts, please do let me know, guys. Any doubt in this particular program, guys? Please do let me know. Yes, please do reply. Okay, I don't see any reply from you, so no issues. Let me basically start with another program. Okay, shall I go ahead with another program? Yes, guys, please do let me know. You can try, Harshit. You can try out this program using the wrapper class. I don't mind. Okay, you can try it out to draw it using the wrapper class. You will have to use a different logic for that. Okay, so let me go to next program. Okay, so in this now what we'll do is now in this list we will do program number 16 today. So this program 16, what does this say? Check this out. Here it says write a program that prompts the user to enter a decimal number and display the number in a fraction. Okay, so basically now this is a reverse way. You now want a decimal number, and now from the decimal number you want to display a number, that number in the fraction format, right? What does it give the hint as? Hint is that read the decimal number as a string, extract the integer part of it and fractional part from the string itself. Okay, so these are some of the operations that we have to do. We have to read the decimal number as a string format, then extract the integer part of it, and also a fractional part from that. So for example, if I give the number 5, right, then this number 5 can be represented, let's say if I give as number 10, then this number 10 can be represented as basically, we can say 20 divided by 2, something like that. Or if I say number 5, it can be represented by as 10 divided by 2, something like this, right? Or if you give, let's say 2.5, then this can be divided as what? 5 by 2, something like this, right? So let's check that out, right? Here basically we'll make sure that we have this kind of number that has a decimal point inside it. Okay, so check this out. This is practical GT practical 16. Okay, what does it say? Prompt the user to enter the decimal number and display the number in fraction. Let me first run it and show it to you how does it run, and then you will see. Check this out. Here I say, it says please enter a decimal number. I say 5. I enter 5. When I press enter, it gives me given number is not a valid decimal number. Okay, so yes, what you have to do, check this out. Let me run this program. I click on run. Check this out. Here it says please enter a decimal number. I enter something like 2.5. Enter, it gives me number in fraction is 5 by 2. Similarly, if I again run this, says please enter decimal number. I say 7.5 and I enter it out. It gives me number in fraction as 15/2. You see that? Right? Okay, some other value like 2.3 gives me something like this, 23.10. You see that? It gives us exact value. It gives us what? Some exact values, right? Okay, so you can see that when we enter 2.3, it gives us 23/10. Okay. Now we have two parts over here. In this program, we have two parts. Check this out. In this program, we have a main method, and inside that main method, we have used this rational class. Okay. In this rational class, we basically will be dealing with the code that will convert, that will read a decimal number, extract the integer part and the fractional part of the string, and will convert it into a fraction number. Okay. So okay, so in this program, this is GTU practical number 16 program. In this program, we have first part, that is this main method. What does it do? Let me show it to you. This main method basically, in the starting, it uses this input object, scanner object called as input. Here we give it a message to the user by saying that please enter a decimal number. So user enters a particular decimal number that is read in the form of a string. And it's input.next that reads the decimal number and it reads in the form of a string and puts it into the string variable called as number. Then we close this input box and here what do we do? Check this out. We can close it in the end also. So see here we say, since this number is basically a decimal, a number with a decimal point value, so we can split it out. We can split it on dot. What does this dot do? Dot is the integral part of the number. So for example, if the number is something like this 5.5 or maybe let's say 2.5, So the number is split into two numbers, two values. One is 2 and another is 5. Okay, in first value we get 2 and in the second value we get as 5. Okay, and right now it is string only. These are simply the strings only. Okay, with a number dot split depending on a dot value. Now see, this dot has a special meaning. So what do? We use backslash backslash dot. So it means use dot literally, use dot as it is and try to compare it with a dot value only from the string. Okay, does not take its special meaning. So once that split has been done, right, we check that the length, if it is length is not equal to 2, it means that the number is not having a valid decimal point value. Okay, the number is not having a valid decimal point value. So we say given number is not a valid decimal point number, and then we exit out of the system. If that is not the case, then it means that we had a number that had a dot inside it, so we were able to split it out properly. Okay, so now what do we do? Check this out. Once that is done, we give that number string value, number which is in the string format, to this rational object by saying new rational number. And then from that rational object, we generate the fraction by saying number in a fraction is this rnum variable is the object of rational. So we say rnum dot get numerator, and then we concat to that string this division operation, or simply the slash forward slash which represents the division operation, and then we concat to it what? Then we concat to it the denominator by saying rnum dot get denominator. Okay. So this is how we basically get the numerator and denominator from the number, from the rnum rational object. But how do we get that? Let's see. So see what happens when you give this number which is in a string variable to this rational constructor. What happens? Let's see. In this class rational, we have two instance variables. One is numerator and denominator. And inside this rational constructor, you can see that it gets a string parameter. It gets a string parameter called number. Then we split it into, we first, before splitting, what do we do? We say number dot index of dot. We get the index of this decimal point which is there inside the string. Okay. Okay, so here when we call this rational constructor, what happens is this string is passed over here. Then we get the index of this decimal point. We get the index of decimal point from the string, and we call it as position, decimal position. Then check this out, what we do. Then we say number dot length. Okay, number dot length minus decimal point, decimal position minus 1. Okay, whatever that particular decimal position is, okay, subtract it from the total length and subtract 1 from it also. Okay, because we know that the indexes of string also start from 0, so we subtract 1 more minus 1. Okay, we already are subtracting this decimal point value and then this one. So whatever that value is, we want basically that that particular length, whatever that length is. Suppose if we have entered, if we have entered like 2.5, right? So we want the length of this, right? So the total length is 3. Out of 3, you are subtracting these two, decimal position and all 1. You get length of this only. That is 1. So what does it do? Math dot power 10 raised to 1. Okay. In fact, basically you get. So once you get that, what do you get? You get the denominator. Okay. You get the denominator. And basically, see, out of that you convert it into int only. Okay, convert it into int only. And then when you say double dot parse double number, whatever the number is, you parse it into a double value and you multiply it by the denominator, right? Then you get the numerator. And then you say normalize. You call this method called as normalize. So what does this normalize method do? Check this out. This normalize method in turn basically calls this GCD method, where it passes both numerator and denominator. These are what? These are the instance variables, right? There basically it calculates the GCD, that is greatest common divisor of both the numbers. Okay, it starts with int I equal to 1 to I less than 1. Okay, and for in each iteration it checks if number 1 is modulo I is equal to 0 and number 2 modulo I is 0, then GCD is equal to I. So if there is an I value, starting from num1 to num1, okay, from 1 to num1, if there is an I value, that which I value is able to divide both the numbers. When is it possible to divide both the numbers? When the modulo returns you 0, it means that both of the numbers are divisible by basically I. Then we say GCD is equal to I. Okay. And if there is one more number greater than that, then we assign that I to the GCD again. So that older number gets overwritten by the newer number. So once the loop ends, we have the greatest common divisor with us. So we return that. Okay. So once we return this greatest common divisor, what do we do? Check this out. We say these dot numerator is equal to this dot numerator divided by GCD. We divide the numerator by greatest common divisor, and we also divide the numerator by the GCD. You see that? So the numerator and denominator are divided by the GCD. Okay. So that is called as normalization. This is normalizing of the numerator and the denominator. So once the object has been made, right, we have this get numerator, set numerator, get denominator, set denominator methods. So getter setter methods are there. So what do we do? Check this out. Once the rational object is created, once we pass this number string format to the constructor of this rational class, in that it basically does what? It basically gets the decimal position of the decimal point number. Then accordingly it calculates the denominator and numerator, but these needs to be normalized, right? These needs to be normalized. So what do? We basically call this normalize method, which in turn gets the greatest common divisor out of for the both the numbers, and accordingly divides both the numbers and resets the numerator and denominator, so we get a normalized value. And now then, once that object is created, we then after that we display saying the number in a fraction is this. From that object we get the numerator, and then we put the division sign, and then we put the denominator. So check this out. We say enter decimal number. If I say it's like 5.2, suppose I say over here 5.2, it gives me 0.6 divided by 5. You see that? Right? You can see it gives us proper value, right? If I, what if I want to debug? Let's try to debug this out. I say debug, and let me put some okay. Let's debug it out by clicking on debug, and it says please enter decimal number. Okay, and so the program is already over here, right, where we have not put any particular watch point. So I say number is 2.5. Press enter. Here it is. Check this out. Here the control has come. This line has been highlighted. What is the number? If I put my cursor on it, you can see that there is nothing but 2.5. You see that? This is the string that has been read. Okay. So if we check this whole thing, the length of this. Okay. Now let's do one thing. Let's say step over. It goes ahead. So it does not go into the if part. It does not go into the if part because that's a valid decimal number. So directly jumps on to over here for creating a new rational object. So I again say here I'll just step into, and it loads the class. Here it is. So here I say, check this out. Here it went into the rational constructor. If we see what is this dec position, that is 1. The decimal point position of this point is 1. It's not even 0, it's 1. You can see why, because this is, see, it's like this. When the number is 2.5, this is 0. Let me put it over here. This is 2.5. So basically what happens? This position is 0. This position is what? This position is 1. And this position is 2. Okay. So what do we get? Where we say decimal point, decimal position of number dot index of dot is, we get 1. Right? Now we say number dot length. What is the length of this number? 1, 2, and 3. 3 minus decimal position, that is 1 minus 1. So it's like 3 minus 2, that's 1. So this thing, this number dot length minus this decimal position minus 1 gives you result to be 1. You see? Then similarly, what do? You put it to the power 10 raised to power that 1, so that gives you value 10. So denominator has value 10 right now. If you see denominator, it has got what? It has got value 10. You can see this value is 10. And if you see the numerator, that is parsed, that value is being parsed into the number value 2.5 is passed into a double value, that is actual 2.5, and then it has been multiplied into denominator, that is 10. So it gives you 25. You can see over here The value of denominator is 10, value of numerator is 25. Okay. So now you have 25 divided by 10. Numerator is 25 and denominator is 10. But that is actually not a proper fraction, right? So we go on to this normalizing. Let's go to that normalizing part. So we came over here in normalizing part, and it called this GCD. So we went over here. So check this out. Here, what is the num value? Num value is 25. Num value is basically the numerator, and the second value is denominator. Okay. This num value is what? Its value is right now 25, and num2's value is 10. So we start from 1 to 25. Okay, and in between that we see which is the highest I value which can divide both 10 and 25. So we get our GCD. Okay, check this out. Once we finalize this, let me put my over here and let me continue and check this out. The GCD would have been value as 5. So the 5 is the greatest common divisor of both the numbers 10 and 25. What do we do now? See, check this out. You have numerator as 25, denominator as 10. So we divide this numerator by 5. It is GCD. So we will get what? Right now it is 25. As soon as I run this, I get numerator as what? 5. And right now denominator is 10. But as soon as I run this, I get the denominator value as what? 2. Check this out. Now the numerator is 5. Denominator is 2. Right? So now again I say go ahead, and here it is. Here we come, and we display this part, and I say continue. And that's it. We get the number in fraction as 5 divided by 2. Numerator is 5, 2 is the denominator. Okay. Actually, it would have been what? It would have been 25 by 10, but instead of that, we divided it by the greatest common divisor, that is 5. So actually, it would have been something like this. This answer should have been something like this. Instead of 25 divided by 10, we divided both by 5, and we got what? We got the value 5 divided by 2. See that? Right? That's what is happening right now. Okay. So this is how this program has been defined or designed. Okay. So please do this program. Try to run this program and try to run it for different inputs. Okay. For example, if I run this and I say I want the decimal number to be, let's say, 17, let's say 15.5. Enter. It gives me what? Fraction as 31 by 2. Right? If I say run it one more, I set decimal number to be 3.16666. Enter. It gives me, oh my god, a very big number, right? 3.16. Suppose I say 3.4, it gives me 17 divided by 5. You see? So the number, fraction number needs to be proper number. Okay. Suppose I say 2.25, it gives me 4 divided by 9, 9 divided by 4. Okay. So there it is. Make sure it's small decimal point number, it's not a larger, bigger one. Okay. Okay. So that's it for this particular program, practical number 16. I hope you don't have any doubt in this. Please do let me know if you have any doubt. Yes, guys? Any doubts on this particular program? Please do let me know. Yes? Okay. So I have uploaded both the programs. Okay, guys, I have uploaded both the programs onto the specifically the repository. Please do check it out. Okay. Okay, you want to understand the rational class? No issue. I'll again explain it out, Dirga. Okay, so check this out, guys. In this practical section program, what we'll do is I will debug it once again and show it to you how this rational class works basically. Okay, so let me take the same example. Okay, let me say debug, and it says enter decimal number. So I say 2.5. So 2.5. I enter 2.5. I press enter, and as soon as I press enter, the control goes over here. You can see this particular control bar has given to me. This is debug control, and it has read the number, and now it has come over here. Here, what do? We check whether after splitting the number, the length is not only equal to only 2. It should be greater. Okay. So once we split it, let's check whether this number is valid or not. I say step over, and there it is. This one is valid because 2.5 is a valid decimal point number. Okay. Then what do is we pass this number value, which is nothing but you can see over here. If I put my cursor over here, it will show you the value is 2.5. Right. So this 2.5 value is being passed to this rational class, the constructor of the rational class. Okay, so let me say step over. As soon as I step over, you can see the control has gone to this rational constructor, which takes the argument as the string number in the string format. Then what do is once we get it, okay, once we get this number, we get the decimal position of the decimal point. So we say number dot index of dot. Okay, so currently if it is 2.5, and the index of this dot is nothing but 1, right? Index of, you can see if I click on this, I put my cursor on this, you can see that the decimal point value is 1. You see that? So the value of the decimal point, that was, the number was 2.5, the location of this 2 is 0, location of this dot is 1, location of this 5 is 2. So we get this 1 when we say number dot index of this dot. Okay, once we get that, what do? We use this value 10. We say math dot power 10 raised to the length of that particular number minus the decimal position minus 1. So right now the value of this is what? The location of this is 1. So this, what is the number length? Number length is basically 3, right? Number length is basically what? Number length is 3, because there are 3 characters. And we say 3 minus, what do we have? Decimal position as? Decimal position is 1, and then we say minus 1. So this is equivalent to what? This is equivalent to saying 3 minus 2, which is equal to 1. So it means 10 raised to power 1. So this makes what? This makes this math dot power results into 10 raised to power 1. So that is obviously 10 only. So if you see, if I put my cursor on this, you can see that the value of this denominator is 10. Okay. Then similarly, what do we do is we convert this number into, we parse that number. What is the number value? Number value is 2.5, right? Number value is 2.5. So we parse it into an actual double value and then we multiply it by denominator. Denominator is the part that is beneath the slash and numerator is on top, on above. This is above and this is below. So we multiply this denominator into this number. Okay, both have been, you can see both have been retrieved as integer values, right? So denominator is also integer 10 and numerator is multiplying the number, actual number, by parsing that number from the string into double value and multiplying with denominator. So it gives you what? From string was basically 2.5, right? So since the string was 2.5, it became 2.5 into 10, which resulted into 25. Okay, and then denominator is 10. So denominator is 10, and now numerator has become 25. So in fact, it should look something like this. Numerator is on top, 25 divided by denominator, which is 10. But this is not a good fraction. There would be some greatest common divisor in between both, right? Which can divide both, right? So we do what? We try to normalize these two numbers. We try to normalize these two numbers by finding the greatest common divisor in between both and dividing these two numbers by that particular GCD. Okay. So as soon as I say over here step over, it goes into this normalize, and then it calls this GCD method where it passes what? Where it passes this numerator, which is 25, denominator, which is 10. So check this out. In this GCD method, num1 is 25, num2 is 10. Okay, so it's something like this, that in this GCD method, num1 is 25, num1 is 25, num2 is 10. Okay, so what we have to do is we have to run the loop from 1 to obviously 24. Okay, and then from each of that number, we try to divide num1 and num2 by I. So for example, if I value is, let's say the I value starts from check this out. Here we have I value to be what? I value is 1, then we have 2, then 3, then 4, and then we in the end we will have 5. Okay. it will go to, this will go up to what? This will go up to 24, because the loop goes from 1 to num less I less I equal to 1 to I less than 1. So 24 will be less than 25, right? So I goes from 1 to 24. Okay, and in each loop iteration, it checks whether num1 is divisible by I and num2 is also divisible by I or not. So let's check this out. Let's check this out. So you can see num1 and num2 are same only. Num1 is 25. Here also it is 25. Here also it is 25. And here also it is 25. These two numbers, original numbers, are not disturbed at all. Okay. Okay. Now you can see that what happens is, you obviously find when the I value reaches to 5. Okay. Now let us check whether these two are correct or not. Num1 modulo I and num2 modulo I. Okay. Let's check whether that is true or false. So here we say num1 modulo I equal to 0. Okay. We write it short. I say num1 modulo I equal 0, and num2 modulo I equal 0, right? These are the two conditions. So whether these two conditions appear true or false. 25 and 1, 10. Okay, but that does not result into 0, right? So okay, here it results into 0, right? This results into 0. So what will be the value of what? Of GCD? Well, right now the value of GCD becomes 1. Okay. Then check for each and every number. Each and every value of I will check. Okay. For each and every value of I we check. 25 and 10 divided by 2, modulo 2 is equal to 0. Yes, true. So what happens? The GCD becomes 2. That is divisible by 3. Well, no, it results false. Then 4, well, no, it results false. Then by 5, yes, it results into true. Now if you go further than this numbers, any of these numbers, none of the numbers would be able to divide both, even 10 or even 25 or even any other value. So what happens is, we get the 5 as the last GCD in this whole iteration, which starts from 1 and goes up to 24. In this whole iteration, we get the GCD to be 5. You see that? Others, consider any other number, 6, 7 up to 24. None of the number will be able to divide both of this. So the GCD that we found over here is nothing but this value I, that is nothing but 5. Right? So you can see we assign I to GCD. If this is the case, what is the case? If both the numbers num1 and num2 are divisible by I, then we assign the value of I to GCD. So once we have found the GCD, what do? We simply divide these two numbers by GCD. Simply divide these two numbers by GCD. What do we get? We get over here 5, and over here we get 2. So that is normalization process, right? First you find these two numerator and denominators, then you find a greatest common divisor out of it, divide it, and normalize the fraction. That's it. Okay. So what do we do in the end? Check this out. See, with each iteration, it does not go inside. Now it has gone inside. So let's see what is GCD value. GCD value is 5. You see that? GCD value has become 5. Now if you again run this, it does not go into if. You can see the control is transferring from if to for, not inside the if block. What is the value of I now? I value has reached up to, you can see if I bring my cursor over I, it shows me that I value is 16. So I again continue. What is the value of I now? Still it is 19. You can see it is not going to, right now it's 24. So if I say now step over, it goes out of it. That's it. Now, what is the GCD value? You can see over here, GCD value is 5. So this GCD value gets returned over here, and that numerator and denominator are divided by GCD value. You can see. So numerator becomes what? Out of 25 it becomes 5, and denominator was 10. So it will become what? It will become 2. You see that? Numerator, if I bring my cursor on numerator, it is 5. If I bring my cursor on denominator, it is 2. See that? So now it is created also in this. So in this rational constructor, it creates denominator and numerator and also calls the normalize method to normalize them. So now this numerator and denominator have been created inside the rational object. So as soon as you go to the next statement, we are printing out the number in fraction by getting the numerator from the rational number and getting the denominator out of it. Okay. And we display it out. That's it. So if I run this, I say continue it, and that's it. You can see number in fraction is 5 by 2. See that? Right? This is how it goes ahead. Okay. Let me again run it for some other programs, for other values. Let me run it from here. I say run. Okay. So we say please enter a decimal number. I say 3.5, and it gives me the output as 7 by 2. You see that? So that's it. That is how we get a decimal point number and convert it into a fraction value. Okay, with the help of a class called rational. It's as simple as that. So please do try it out, guys, and if at all any doubts, please do let me know. Okay. Still any doubt, Durga? Are you able to understand it? Did you get the how this rational class has been created? Did you understand that? Yes, Durga? Please do let me know. Please reply. Okay, that's great. That's good. Anyone else having any doubt in this particular program? Please do let me know. Okay, guys, you can try it out. I will put it on my repository. Please check it out. Okay, I already put it onto the repository. Please check that particular programs, and please do let me know if at all any issues in that for running. Okay. Yes, guys, tell me, are you able to download it from the repository and are you able to run it or not? Please do let me know. See, these two are big programs, so I do need to get the feedback from all of you whether you are able to understand it and able to run it or not. Okay. I've uploaded the latest practical 15 and 16. Who can download it and run it and show it to me? Yes, guys, please let me know. I want some output from you now. I want to see whether you people are able to run it or not. Who will show it to me? Tell me. Yes, guys, tell me who will be who will show it to me. Okay, Arshit, no problem. Go ahead and show your screen. Okay, Arshit, I can see your screen. Go ahead. Okay, good. No problem. Okay, so we can have interaction now. I'll stop the recording, and if you have any doubts, you people can ask me. Okay.